This is section 11.7, strategy for testing series. So these are the different tests that we have for series. We have the P series. If P is less than 1, then it's divergent. And if P is greater than 1, then it's convergent. The geometric series says that the absolute value of R is less than 1, then it's convergent. We have the comparison test. We have the test for divergence. If the limit does not equal 0, then it's divergent. We have the alternating series test, the ratio test, the root test, and the integral test. So you just have to look at the problem and determine which of these tests to use. For this first one, it looks like a comparison test because we know that n minus 1 over n cubed plus 1 is less than n over n cubed plus 1. All right, that's because the numerator is bigger here. That makes this bigger than this. And we can also say that this must be less than n cubed. Whoops. Because the denominator is smaller, which makes the fraction bigger. And that is equal to 1 over n squared. And since this series is convergent by the P series, that means that this will also be convergent by the comparison test. So since 1 over n squared is convergent, P series, P equals 2 greater than 1, then the original series that we started with is also convergent by comparison. All right. This one, as you can see, these are both raised to some form of n, which means the root test makes the most sense. So the root test would be the limit as n approaches infinity of the nth root absolute value. Okay, so when you take the root, the n's are going to cancel out, and you're going to be left with the limit as n approaches infinity of n squared over 1 plus n to the third. The greatest power in the denominator would be n cubed, so we need to divide by n cubed. So this limit becomes 1 over n, 1 over n plus 1 cubed. These go to 0, and so overall the entire limit is 0, which is less than 1, which makes it convergent by the root test. All right, this next one looks like a comparison test again, because this fraction can be compared to we can say that this is less than this because the denominator is smaller, which makes a fraction bigger. And this is just k, so k times k is k squared, so this becomes 1 over k squared. And once again, since this series converges, then this series must converge by the comparison test. Since 1 over k squared converges, it's a P series with P equal to 2, which is greater than 1, then the original series that we started with is also convergent by comparison. All right, let's look at the next problem. All right, so this one is a little odd because of the sign. So the largest value that sign can be is 1. So if it's 1, you're going to get 1/3. And the smallest value it could be is -1. So the other value would be 1. So this is going to vary between 1 and 1/3. So we're going to use the test for divergence. So if we have this, this is going to become, well, like we said, it's not going to exist. It does not exist. The limit will not exist since the values will vary between 1 and 1/3. Thus, the limit does not exist. Therefore, the series is divergent by test for divergence. So if you recall, the test for divergence says that if the limit does not equal 0, then it's divergent. So that's what the test for divergence tells us. Okay, so this one looks like a ratio test because you have an nth power, but you have an n here as well, but it's not an exponent. So this would be a ratio test. So the ratio test would look like this. All right. So I am doing the a sub n plus 1 divided a sub n, but the a sub n I'm multiplying by the reciprocal instead of doing the division. All right, so this one can be broken up, and so the new limit will look like this. Notice that the 5 will come out, so that's 1/5. So that's going to be 1/5 limit of n plus 1 squared. We can drop the absolute value because the values of n are all positive. And here we're going to divide by the highest power of the denominator, which is n squared. So if we divide all these terms by n squared, you're going to get 1/5 limit. This would be 1 plus 1 over n squared plus 1 over n squared, 1 plus 1 over n squared. And these terms will approach 0. So you're going to end up with 1 squared divided by 1, which is 1. 1 times 1/5 is 1/5, which is less than 1, which means it is convergent by the ratio test. And that does it.